Yeah. Okay. Long division. So you got to divide this polynomial by x plus 4. See ya. So look, if you do that long division, you're going to go x cubed minus x squared minus 14x plus 24. And you're going to divide that whole thing by x plus 4. Now, they actually don't care about what the answer is. So the answer is going to be found using long division, but all they care about is the remainder. So they don't even care about the answer. So if they only want the remainder, they want you to use the remainder theorem. They want you to do a shortcut. They don't want you to do long division. So it says they're prompting you. The remainder can be found by evaluating f of. So because you're dividing it by x plus 4, the remainder theorem is this. Here's the shortcut. If this is a 1, we are going to take the opposite of 4. We're going to take a negative 4. We are going to plug a negative 4 in wherever there's an x. So we're going to plug a negative 4 there. So wherever there's an x, put in parentheses. So go parentheses, negative 4 parentheses, cubed. So replace this x with parentheses, replace this x with parentheses, replace this x with parentheses, and then you just type it in one command on the calculator and you're in business. So I'm going to go minus that x, I'm going to do parentheses, put a negative 4 squared minus 14 parentheses, negative 4 parentheses plus 24. Okay, now if you just type that in exactly how you wrote it down, you have to include the parentheses or your calculator is going to mess it up, and hit enter. That will give you the remainder. So negative 4 cubed, subtract parentheses, negative 4 parentheses squared, subtract 14 parentheses, negative 4 plus 24. I got a 0. So that means there's no remainder. Negative 4 parentheses. Okay, I got a 0. So if you calculate that all out, it gives you 0, which means this. The remainder is 0. There is no remainder, so it went in evenly. And you could do it the long division way and double check, but I think we're going to do long division on the next problem or two. So big idea is this. If all they want is the remainder, you're going to substitute in place of the x's a minus 4. Okay, if you were dividing by x minus 4, so say you're dividing by x minus 4. If you were dividing by x minus 4, then what you would substitute in place of the x's would be the opposite of this. It would be a plus 4. So whatever this is, you plug in the opposite. Okay, let's look at this polynomial. Given a polynomial and one of its factors, find the other factor. So they want you to do long division. So you got x cubed plus 3x squared minus 6x minus 8. They want you to divide that by x minus 2. Okay, so let's do the long division. And we will find the other factors. So the factors are what times together to give you this polynomial. So this x minus 2 times something, and we're going to find it. So here we go. I just look at x, and I look at x cubed. What can I times x by to turn it into a x cubed? You gotta times it by an x squared. So x squared times x will give me the x cubed I wanted, but I gotta times the x squared to the minus 2, and that is a minus 2x squared. Okay, now you gotta subtract them. So I'm gonna turn that to minus, I'm gonna subtract that, which turns it actually to a plus. So these are 0
and this is 5x squared. Bring down my next term. My next term is a negative 6x. I'm only going to focus on the 5x squared and the x. What can I times x by to turn it into a 5x squared? Times it by 5x, so 5x times x is 5x squared, and 5x times a minus 2 is a minus 10x. Okay, now you gotta subtract. So I gotta subtract this, and I gotta subtract that, which will make it another plus. So these two will zero out, and these two combine and give me 4x. Bring down my next term, minus 8. Focus only on the 4x and the x. What can you times x by to turn it into a 4x? Times it by 4. So 4 times x will be 4x, and 4 times a minus 2 is a minus 8. Subtract them. So that will make that a plus. That is 0, that is 0. So my remainder is 0. So that means x minus 2 times x squared plus 5x plus 4. These are my two factors. Now, this guy, I'm going to break down into even more factors. So we're going to go x minus 2. There we go. We should have 1, 2, 3 factors, because you can factor this. There are numbers that will times and give you 4 and add and give you 5. So you can turn this guy right here into x times x gives you the x squared. What times this gives you 4, adds and gives you 5. That's 4 and 1. And then everything is positive, so everything is positive. X plus 1, x plus 4. The order doesn't matter. We can go x plus 1, x plus 4. So this is the final answer they're looking for. These are the three factors. If we times all these three together, it will give you this polynomial, x cubed plus 3x squared minus 6x minus 8. Okay, so that's done. Now let's look at A and B. A, okay, all they care about is the remainder. So if all they want is the remainder, if we were to divide this by, not by x minus 2, if we were to divide it by x minus 1, so that means this, the shortcut is going to be this. Take the opposite of this, so we are going to take 1. We are going to plug 1 in to the function. So we're going to take 1, and anywhere there is an x, put parentheses, 1 cubed plus 3 parentheses 1 parentheses squared minus 6 parentheses 1 parentheses minus 8. Okay, now the parentheses really make sure your calculation's correct when the number's negative. When the number's positive, it's much easier. And since the number's 1, we can do this guy in our head. So 1 cubed, 1 times 1 times 1 is 1. 1 squared is 1 times 1, that's 1. 1 times 3 is 3. 1 times negative 6 is minus 6. So this is what we got. 1 plus 3 minus 6 minus 8. 1 plus 3 is 4. 4 minus 6 is a minus 2. Minus 2 minus 8 is a minus 10. So this remainder, A, you end up with a minus 10. Now B, what if you were to divide it by x plus 3? So not x minus 2, but you're dividing by x plus 3. So if you're dividing by x plus 3, we're going to take the opposite of this. We're going to take a negative 3. And we're going to put a negative 3 in that x, in that x, and in that x, and that will spit out the remainder. So here we go. So wherever there's an x, put parentheses, and this one's a negative, so this is super important. Negative 3 parentheses cubed plus 3 parentheses negative 3 parentheses squared minus 6 parentheses negative 3 parentheses minus 8. Okay, this one I'm not even going to try to do it in my head. I'm just going to type that in on the calculator, hit enter.
So, here we go. Parentheses negative 3 cubed. Plus 3, parentheses, negative 3, parentheses, squared. Minus 6, parentheses, negative 3, parentheses, minus 8. So if I hit all that in and hit enter, it gives me that all equals 10. Okay, this one. Given that f of a negative 4 equals 0, so that means the remainder is 0 when you plugged in a negative 4. So that means the remainder is 0 when you divided by, so if they plugged in a negative 4, they must be dividing by x plus 4. Because you take the opposite of that, which would be a negative 4, and then plug into all these x's. So if you plug a negative 4 into that x, into that x, into that x, it should spit out a 0. So that means you divided by x plus 4. So they want all the factors. So one of the factors is x plus 4. So we can kill a. It's not going to be a. So one of the factors has to be x plus 4. So here we go. To find the other factors, we have to divide. So we're going to go x cubed minus x squared minus 14x plus 24. And you're going to divide that by x plus 4. Okay, so let's do some long division. Okay, now just focus on this and this. So what can I times x by to turn it into a cube? Times it by a square. X squared times x. There's my cube. X squared times 4. That's 4x squared. Okay, now you got a minus. So I got to minus that, and you got to minus that. Those are 0, and these combine to give you a minus 5. X squared, bring down my next piece, minus 14x. Okay, only focus on this and this. So what can I times x by to turn it into a minus 5x squared? Times it by a minus 5x. So minus 5x times x is a minus 5x squared. A minus 5x times 4 is a minus 20x. Now you got to subtract. So you got to subtract that and subtract that, which is going to actually turn them both to positives. That's 0. And that is 6x. Bring down my next term. Bring down 24. And what can I times x by to turn it into a 6x? You got to times by 6. So 6 times x will give me 6x. 6 times the 4 will give me the 24. But now you got a minus, and they both 0 out. So my factors are x plus 4 times this guy. X squared minus 5x plus 6. And this one can be broken into two different factors. I can factor this. How they times to get x squared is x times x. How they times to get 6, but add to get 5 has got to be a 2 and a 3. But they add to get a minus 5. So they both must be minuses, because a minus times a minus is a positive, and a minus 2 plus a minus 3 is a minus 5. So x plus 4, x minus 2, x minus 3. So we're going to go D. That matches up with D. Okay, now sequences. Arithmetic sequences, they grow by, they're linear. They grow by addition or subtraction. Geometric sequences, those are exponential. They grow by times. So here we go. If you try, first if you try arithmetic, so you do the difference between a negative 8 and 2. And a negative 8 and 2, it's growing. So a negative 8 and 2, that's like plus 10. So that means it's got to be plus 10, plus 10, plus 10, plus 10. Now the difference between 2 and a minus 0.5 is definitely not plus 10. So this one is not arithmetic. So now let's try for the geometric. Geometric grows by times. So take this one and maybe divide it. So I'm going to do on my calculator negative 8 divided by 2. So negative 8 divided by 2. Okay, that means I'm dividing by a negative 4. Now I'm going to do the next one. 2 divided by negative 0.5. 2 divided by negative 0.5. Okay, that worked. From here to here, I divided by a negative 4. And let's check the last one, because it's got to work every time. You must be dividing by negative 4. So I'm going to check one more. Negative 0.5 divided by 0.125. 0.125. Okay, that worked. From here to here, I divided again by a negative 4. So this one is geometric. Okay. I'm going to see how it went. Negative, positive, negative, positive. This one goes negative, positive, negative, positive. So the only way it can go negative, positive is if you times or divide by a negative, because that'll change the signs back and forth. So going from here to here, now negative 2 to a 6, I'm going to take the bigger number divided by the smaller. So I'm going to go 6 divided by a negative 2. And that is a negative 3. So, to go from here to here, and you can kind of see that hopefully with some mental math, you times it by a negative 3. And does that hold true all the way through? From here to here is 6 times a negative 3, negative 18, yes. Is negative 18 times a negative 3 a positive 54, yes. So this one's growing by multiplication. So it is geometric. Times by the same thing every time. Okay. This one looks like it might be linear, might be arithmetic. So 7 to 12, that changed by addition 5 times. 12 to 16, that changed by addition 4 times. That changed by addition 4 times. So it's not arithmetic. It's got to be plus 5, plus 5, plus 5. Same number all the time. So try for geometric. So I'm going to do 12 divided by 7. 12 divided by 7 is some decimal. It's awful. 1.714285, blah, blah, blah. So I'm going to try 16 divided by 12. 16 divided by 12. If it gives you the same decimal, you might be in business. It gives you a different decimal, so it is neither arithmetic nor geometric. Okay, let's try the last one. So the difference here, I'm going to try first by arithmetic, because it looks like it might be 5 to a negative 6, that went down 11 times. Negative 6 to negative 17, that went down a negative 11. 17 negative 28, that went down another 11. So minus 11, minus 11, minus 11, minus 11. So that one's arithmetic. Okay, now let's get complicated. They want you to find the indicated term for each arithmetic sequence. So they want you to find the 19th number in the list. So this would be the first, this would be the second, this would be the third, fourth, fifth, sixth. They want the 19th. Now let's see how this pattern is growing. So it looks like it's plusing. It's getting bigger, bigger, bigger. So 32 minus 16, that's 16. This guy, 48 minus 32, that's 16. Okay. Now, the whole key behind arithmetic sequences is this. Y equals mx plus b. That is the key to everything. That is used to give you whatever you want in probably any type of answer. So first of all, let's see if we can find y equals mx plus b. And you actually just found m. So the first one is going to be 16. The second one is 32. The third one is 48. And we're going to skip. We want to know what the 19th one's going to be. Okay. So we found the m. That's 16. That's 16. We need the b. The b happens right here. The b happens at 0. So go back one. And if you go back 16, that 0 should be 0. So your formula is y equals 16x. We don't really need to write the plus 0. You can if you want, but okay, that's the formula to give you all the x's and y's you want. And you want the 19th x. So you are going to take 19 and put it in place of the x, and that will give you, to find the y, all you got to do is times it by 16. So the y is going to equal 16 times that 19th x. So if we do 16 times 19, that y is going to be 304. So the 19th one is going to be 304. Okay, this next one they give you something totally different. So they give you a sub 1 is 56, d is 13, n is 73. So you gotta remember what all the heck that is. So a sub 1 is 56, that means this. What they're giving you is the very first one is 56. So we got that. N is the end one, so they want to end at 73. So they want to know it's ending on 73. So here we go. So look at the first one. The first one, they wanted you to find the 19th one. That means this. They wanted you to end on 19. So n is the end. They wanted you to end on the 19th one, so we're going to find a of 19. So they want us to end on the 73rd one. That's going to be a sub 73. So these two are kind of communicating the same thing. They want you to end on the 73rd one. So we're going to go blah, 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 73rd. So a sub 1, the first one's 56. The last one is going to be 73. Now this is the slope. That's the difference. So it's going to be 13. So that means the second one is going to be 56 plus 13. So that's going to be 69. I want this, y equals mx plus b. I want m and I want b, and they gave us, that's the m. So the b is going to be right here. Go back 13. So let's do 56 minus 13, and that is your b. So your formula to find all the x's and y's you want is y equals 13 times whatever the x is, and then plus b plus 43. Okay, that's your model. That will give you all the x's and y's, and they want you to find the y when the x is equal to 73. So on your calculator, you need to do 13 times 73 plus 43. Do the math. 13 times 73. So the y is 992. So if you end on the 73rd number in the pattern, the 73rd number in that pattern should be 992 if you go up by 13s every time. Okay, now geometric sequence, that's totally different. That's growing by times. So if it's growing by times, it's going to have a totally different model. So the model for growing by addition is y equals mx plus b, but the model for growing by times is y equals, it was the very first one, times the rate, the ratio at which it's growing, to the n minus 1. Okay, so this was the model for a geometric sequence. Make sure you got this in your notes. To find the model for all your x's and your y's, so we can put actually an x here. Same thing. So to find your y's and x's, you take the very first one, you times it by this exponent, this power. So the base, the r, is how fast it's growing. If you're timesing by 4, timesing by 2, timesing by a half, whatever that is, and you do x minus 1. So here we go. We got a sub 1, and we've got r minus 2. So look, in your pattern, in your table, they give you the first one in the list. The first one is a negative 4. Okay, the rate, or the ratio, you're timesing by a negative 2. So you're going to times this by a negative 2. That means the second one should be 8. The third one times by a negative 2. The third one should be a minus 16. The fourth one times that by negative 2. Every time you're timesing by negative 2. So the fourth one is going to be negative 16 times negative 2, and that's going to be 32. So they don't want you to go very far. They just want you to go to 10. So on your calculator, you can just times it over and over again by negative 2, because that's not really too far to go. But if you want to use the formula, here's how the formula works. Okay, the formula, all we need, so I want this, I want to find the y. Okay, so y, the a sub 1 is that guy, so it's a minus 4, times the rate at which I'm timesing by a negative 2, and I got to put that in parentheses, raised to the, so if I want to go to the 10th one, I've actually got to raise it to the 9th power. I'm only going to times it 9 times. I'm not going to times it actually by a negative 2 10 times. I'm only going to times it 9 times, because the first one is just there. So then you times by negative 2, then you times by negative 2. So you're only going to end up times by negative 2 9 times. So here we go. So now type that in on a calculator. Negative 2 to the 9th power. Negative 2 to the 9th power. Whoops. Times by a negative 4, and you should end up at 2048. Okay, let's look at the next one. The next one, they give you, again, totally different information, but they want you to kind of find the same thing. So x, y, they want you to find the 12th number in the pattern. This is the first, this is the second, this is the third. So the first one is a 96, the second one is a 48, the third one is a 24, blah 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 blah. They want you to find the 12th one. Okay, so your model is y equals a sub 1 times the ratio raised to the x minus 1. And we know this. We know a sub 1. So let's find this. This is how fast the pattern is changing. And it looks like it's getting smaller. So that's division. So I'm probably dividing. So do 96 divided by 48. Enter. You're dividing by 2. 48 divided by 2. Let's check it. Yes. That is it. Okay. So you can start with 24, and you can just divide by 2, divide by 2, divide by 2, over and over and over again. Here's what you got to know. Divide by 2 is equal to timesing by 1/2 or timesing by 0.5. So if you're dividing by 2, that's actually timesing by a fraction. So here we go. I'm going to plug stuff in because now we know to find our y. So to find our 12th one in the pattern, we're going to take the first x, so the first x gave me 96 for a y. So we're going to take that 96. We're going to times it by the rate at which it's growing, which is 1/2, raised to the x minus 1, and I want the 12th. So if I want the 12th x, that means I'm only going to cut it in half 11 times. I'm not going to cut it in half 12 times. So I'm going to cut it in half 11 times. So here we go. Type that in, hit enter, and you should be good. 96 times 0.5 to the 11th. So if you keep cutting in half, you should end up with 0.046875. So you got a decimal. Now let's do the sum of each arithmetic series. Okay, the sum. So the formula for the sum, we're going to add them all up. The formula is folding the line. So you're going to take the first plus the last. And then you got to times that by the number of pairs. So you got to times that by the number of terms in the list. And you're going to divide that by 2 because you're going to create pairs. So you're going to fold this one with this one, this one with this one, this one with this one, this one with this one. So you're going to pair them up. So how many ever numbers are in the list, divide that by 2, and that's your number of pairs. So this is my first, second, third, fourth, I don't know. I don't know what it ends on, but I know that's the last. So I'm going to take the first plus the last. 5 plus 32. Okay, 5 plus 32 is 37. And you need to times that by the number of terms divided by 2. I have no idea how many are in that list. I know it's arithmetic, so it goes by add, and it looks like this is add 3, add 3, add 3. So really quick, I'm going to do y equals mx plus b. Y equals mx plus b. So if I got a table going on here, I know my first one is 5, my second one is 8, my third is 11. I know the last one, the y is 32. Now I'm trying to find this. What is the x? Let's go back. 0 would give you 2. So your formula to find all your y's and x's is y equals 3x plus 2. And you know the y is 32, so you're going to put 32 there. So you're going to go 32 equals 3x plus 2. Now solve for the x. So you got to undo the 3 and the 2. Minus 2, 30 equals 3x. Divide by 3, divide by 3. The x is actually 10. So that means the 10th one is 32. So I did my first plus my last times by the number of terms. There's 10 terms in the list. Divide that by 2. So that's actually 37 times 5. And 37 times 5. If you add all these up, they should add up to 185. That's an awesome problem. Next one. What's up? Okay, so the next one is given to you something totally different. Here is, so that's the mx plus b. That's the formula right there. They want you to start by plugging in 2. So take 2 and plug it in. So it's going to be 4 times 2 plus 1. And that is 9. And then they want you to plug in 3. 4 times 3 plus 1. And that is, what is that? 12, 13. Then they want you to plug in everything. 4 times 4 plus 1. That's 16, 17. keep going, dot, 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 until the last one they want you to plug in is 10. So 4 times 10 plus 1 equals 41. So here we go. This is the sequence. The sequence is going to go 9, 13, 17, blah, 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 plus 4, plus 4, plus 4, plus 4, till you get to 41. So we're going to take the very first 9 plus the very last 41. We're going to times that by how many numbers are in the list. So if you do 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers in the list divided by 2. So that is 50 times 9 divided by 2 is 4.5. So 50 times 4.5, 50 times 4.5, you should end up with 225 is the sum of all those numbers.